Okay. Section 3.5 called parallel and perpendicular lines, equations of them. You did this in Algebra 1. Now I've got to remind you how to handle them. Equations of lines. Several preliminary things I've got to show you first before, and then you'll have those things fresh on your mind so that when I explain what's really going on here, the new stuff, hopefully it'll make more sense to you. So there's several things I've got to remind and reteach and show you before we get going here. First of all, if you have 2 points on the grid, such as A is 3, 7, and B is, let's say, -2, -4. If you've got those 2 points on the grid, do you know how to find the distance between them? Taught you that, right? So we know the distance formula, and it's going to be, for this particular one, the distance is going to be the square root of, this is what we would do, and you can do the arithmetic in your head, but this is what we would do to get it. We would say 3 minus -2 squared plus 7 minus -4 squared. And it doesn't matter the order. Notice I went 3 minus -2. I could have gone -2 minus 3 because I'm squaring that. I'm going to get the positive version of it, right? That would be the distance. Does anybody remember how to find the midpoint between 2 points? Okay, let me remind you. Mid means middle, and middle means average. You know how to do it?
When you add them up and then divide it by 2.
Yeah, the x's and divide by 2 to get the x coordinate of the midpoint. Exactly. It means the average. So the midpoint is a point, and it is found by taking, in this case with A and B, it's found by taking 3 plus -2 and dividing by 2, comma, 7 plus -4 divided by 2, and close it. And whatever these two things turn out to be is going to be the midpoint of that. Let me show you over here on the grid. If I plot 3 and 7, which is right there, and the other one is -2, -4, and I want to find the midpoint, that means if I connected a line right here, what's the coordinates of the middle of that? And what I'm saying is that it's going to be the average. Okay, let me see if I can point this out to you better. If we make a triangle out of this again, like we did with the distance using Pythagorean theorem, then does it make sense to you that and I hope I can draw this straight enough. Does it make sense to you that if I can find the middle of this one and go up to this line, that it will hit it right in the middle of this one? The middle of this, that's going to be 1, 2, 3, 4, 5. That's going to be about 1, 2, and that's going to be about right there. Do you agree? In the middle of this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5 and a half. Should be about right there. Where those two things crash is right there, which should be the midpoint of our black segment. We'll go up, out like this. Does that make any sense to you? Okay. Then the way we do that with the arithmetic over here, with the midpoint formula, is to find the average of the x's. The average of the x's is going to turn out to be 1/2. This is right in the middle of the difference in the x's. You with me? Okay. So take a look here. I get 3 plus -2. That's like saying 3 minus 2. That's 1. Sure enough, 1/2. 7 minus 4 is 3. 3/2. Which is 1/2. Is that where we went up here? Yeah, look at that. The y value is 1/2 right there in the middle. Where those two meet is at the point. 1/2, 1/2. That's the middle of that black segment. Does that make good sense? Okay. So midpoint formula, I only made it specific to this particular thing right here. I'm going to summarize them all in just a minute. And then the other one, there's 3 things you need to know about lines on a grid. You need to know how far apart they are, 2 points. How far apart are they? Where's the midpoint? And what's the slope? Do you remember the slope formula? Howdy. Oh, don't throw it away. Don't throw it away. Thank you. Okay. So the slope of that line, do you remember how to find it? Rise over run. That's how you would do it on the grid. If you had the 2 points on the grid, you could actually count it. And this is what you do. You'd say, do you remember that this was 11? I just already counted it. So I would go up 11, right to there. I'd go up 11 and over, what was it? 5? This was 5, wasn't it?
Yeah.
So I'd have to, I guess I'm not demonstrating this very well. I always start on the lower one and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 until I'm directly across from it and then count over 1, 2, 3, 4, 5. So I get 11 over 5. That's the slope of this thing. That's from counting, and that's how you do it if it's already on the grid. What if it's not on the grid and all you have is these 2 points and you haven't plotted them? Does anybody know how to do that one? Just the opposite, and here's why. Here's why. Rising, you said rise over run. You've all got rise over run memorized, right? Rising from one place to another on this grid is a Y thing, because the Y axis is vertical. Running is an X thing, so it's Y's over X's. And that's kind of weird, because you have to go to the back end of your points first to get the first thing you're going to write down. So it's kind of bizarre, but it's Y's over X's, and so we would do 7 minus -4. And in this case, folks, you do have to do it in the same order. 7 minus -4, if I put that on the top, I have to do 3 minus -2 on the bottom, which would be 7 plus 4 and 3 plus 2, which is what we got when we counted it. You following? Okay, so here's the summary. I'm going to put it right down here so it's kind of out of the way for the rest of the lecture. So I'm going to put this up a little ways. Maybe. There we go. And I'm going to summarize what we just learned right here. So distance formula for A, which is x1, y1, and B, which is x2, y2 in general. It's a generalized idea there. Then the distance is going to be the square root of x1 minus x2 squared plus y1 minus y2 squared. And this is really what? This whole thing right here is really Pythagorean theorem. We said that yesterday, right? Remember? Okay. And the midpoint between those two is going to be x1 plus x2 over 2. The average of the x's, comma, average of the y's. So you're going to add them here because you're averaging. Averaging means add. Finding distance means subtract. That'll help you remember we're going to add or subtract. And the slope, which is little m, is y1 minus y2 over x1 minus x2. Or you could reverse them both, but they got to both be reversed. So whatever order you subtract the y's in, you have to subtract the x's in. Okay, familiar with those? I mean, you've seen those 3 things before. Now they're back in your head, right? All right, so I'm going to erase this. That's one of the things you got to remember. The next thing you got to remember is how to write the equation of a line given 2 points. So there's lots of other things you're going to have to know too. So I'm going to give you a little lecture on lines, lines in general. This form of a line, I'm going to write it up here, and you tell me if you think and be honest, if you have seen this before. You ever seen this before? This is called the point slope form of a line. And the reason why it's called point slope is because to write it, you need a point and a slope. Now think about that for just a minute. If you're going to put a line on this grid someplace, all you need to know is, where is it? And the other thing you need to know is, how steep is it? That'll do it. That'll completely define it. Won't it? If you know a point that you got to run it through, so it's like on a spindle. You stick a point on it right there, and you say, okay, draw a line through there. Okay, it could be that one, could be that one, that one, that one. There's a whole bunch of them. So if it must go through there, and you grab that thing and say it's got to be exactly this steep, that completely defines it. So you need a point and a slope. What do you need to write the equation of a line? A point and a slope. So you need a point and a slope to write the equation of a line. What do you need to write the equation of a line? A point and a slope. What do we need to write the equation of a line? A point and a slope. Do it again. What do you need to write the equation of a line? All right. Now, almost always, until you get to pre-calculus or maybe even calculus, almost always they will give you a point. Some way or another, they will hand you a point. Most of the time, they just hand it to you on a platter and say, here's your point. The point is x1, y1. and it goes right here. The y, again, you're gonna have to go to the back end of your point first. The y1 goes here, and the x1 goes the very last thing you write. So it's backwards. It feels weird, but you're gonna have the back end of your point first. X and y without a subscript are x and y variables. M, of course, is the slope. Now, they'll almost always give you a point, but they will make you go hunting for the slope a lot. They make you go find it some way or another. Sometimes you have to find it this way. Sometimes they say, write the equation of a line through 2 points, and you've got to use this slope formula to find your slope, and then use one of the points here and here. Sometimes they just hand you the slope. However, today, they're going to hand you the slope in the equation of another line. Like, before I get there, though, I kind of jumped the gun. You always, whenever it says in the instructions, write the equation of a line with, and it gives you a whole bunch of information, you always start here. Write the equation of a line. Think this. Once you get this much written, you can go one of two directions. You can go to slope-intercept form of the line, which most people like a lot because you can graph it easy. It's this form. Does that look familiar? And the way you graph this is you go to the back end again. You plot that on the y-axis as a point, leave your pencil there, and then you rise over run this amount and plot another point and connect them. Does that sound familiar to you? That's why this is called slope-intercept, because in this form, you can clearly read 2 points. You can clearly read where to start and how to count the next point out. Another form is standard form, which we're not going to do anything with today, but I just want you to know. Standard form is this: ax plus by equals c, where a and b and c are all numbers, they're all whole, and a is positive. We're not going to go there today. We're going to spend most of our time on this and getting to here and understanding what this means. Okay, there's your review of lines real quick. Now we're going to get to the perpendicular parallel part. I'll leave that up there for a minute. Consider this line with me for just a minute. Let's say I connected this point and this one right here. If I connect those and I connect it not only there, but I connect it all the way on through. Can you tell me, I'm going to make this heavy so that it's a little easier for you to answer this question. Can you tell me what the slope of that line is? It is a half, because you'd have to rise 3 and run 6, and 3 over 6 reduced is a half. Do you agree this line is a half? Then if I wanted to draw a line on this grid that's parallel to this one, and it had to go through, let's say it has to go through this point right here. How could I get a line that's parallel to this one? So you go up 1 over 2, you said? Why am I going to do that? Because the slope of the line that I'm trying to draw has to be the same as that one. Otherwise, they will hit each other. They have to rise at the same rate all the time, or they're not going to be parallel, are they? Okay. So whatever slope this one has is the slope this one's got to have. And I would count out several of these to make sure I didn't make errors. And I would connect that. And those lines are parallel. And I think you already knew this, but lines that are parallel have the same slope. Right? So my question before I move on is this line parallel to this line? They're both lines. That's slope-intercept form. That's standard form. Are they parallel? To answer the question, you got to be able to know what the slope for each of them is, don't you? Okay. What's the slope of this one?
3.
You can all see that because it's sitting where it belongs. What's the slope of this one? What's the slope of this line? How do you find out? What should we do to find out the slope of this line? Yeah, get y alone. In other words, turn it into that. Solve for y is what we say. Solve for y. And so to solve for y, I first get the y term by itself. And what I'm going to do when I solve for y, and you should make it a habit of this too, is when I take this 3x over to the other side, I'm going to tuck it in right after the equal sign and shove the 7 back. Do you all understand that move? You good? And then we divide everything by 2 to isolate the y. And I get y equals negative 3/2 x plus, I don't care. I don't care. I want that. That's all I'm interested in. And it is not 3. So those lines are not parallel. But you can't see the slope unless you are clever with your algebra and able to solve for y. Then the number that sits in front of x, that's your slope. Okay? All right. Now, you know what perpendicular means, right? It's what most streets are. All of these grid lines up here are perpendicular to others that go this way. But what if I consider this line right here whose slope was 1/2 and I want to draw a line which is perpendicular to it? First of all, which way will it lean? The line that's perpendicular to that one, will it lean to the right or lean to the left? It'll lean to the left. And if it leans to the left, what's the sign of its slope? Negative. So if that one has a positive slope, anything perpendicular to it's going to have a negative slope. By the same token, anything with a negative slope is what you're starting with. If you're trying to write a line perpendicular to it, will have a positive slope. Has to. They have to lean in opposite directions to be perpendicular. So they have to be opposite in sign, but take a look at this one. If I was going to just sketch in what I believe is perpendicular, maybe I'll make it hit right here. And I want to go perpendicular, so I'm eyeballing this. Going up like that. Can you see that line that's perpendicular right there? It could be anywhere on here, by the way. But that line right there is quite a bit steeper than that line. Think about it as a ski slope. This one's probably a blue run. Not too bad. Get you a little speed if you want. That thing right there is practically falling off a cliff, right? So this is a strange way of saying this, but the perpendicular line is going to be as steep as this one was shallow. You're going, how do I accommodate that? Well, this one had a slope of 1/2. This one's got a slope of 2. Well, negative 2. 1/2 isn't very steep. 2 is just as steep going this way as this was shallow going this way, if you will. Okay? Yes?
Just like one up and 2 that way.
Yeah. Or you could start here and you could drop 2 and run to the right one. One of your moves has to be negative if you're going to have a negative slope. So if you rise, that's positive. You're going to have to run left to hit it. If you drop, you've used up the negative and you got to run right. So either way, yep.
So if one like parallel, you just take the negative reciprocal.
That's exactly what it is. That's what I was going to bring up right now. That's good that you observed that. If you want to know the slope of a line perpendicular to this line, you find the slope of this line, which is 1/2, and you turn it over and change its sign. Okay, so let's stay here on the grid for just a minute and practice one more. I'm going to put a line up here, and I want you to tell me the slope, not where it is, but where the slope of a line perpendicular to it. So if I put a point here and a point here, no, I'm going to go over here instead. Okay, so there's the line, and it's hard to draw on this slick surface and make it straight, but there's your line. What will be the slope of any line perpendicular to this one? She said, you can't see it very well?
Yeah.
Shall I count for you? You want me to find the slope for you?
Sure.
Okay, so I always start on my lower point. This is going to count up. I'm going to count up. It's on directly opposite of this, and that would be 1, 2, 3. Okay, and then over 1, 2, 3, 4, 5, 6, 7. So this was 3, and this was actually, because I had to run left. This is actually -7. Do you understand that? Because I had to run left. So the slope of this one is -3/7. And people go, no, it's not -3/7. It's 3 over -7. I need you to understand this about fractions. 3 over -7 is the same as -3/7 is the same as -3/7. They're all the same as long as there's a negative someplace. Doesn't have anything to do with which one of these was negative when I ran and ran. It's just that the fraction, which is the slope, is a negative number. We can tell that because it's rising to the left. So I got -3/7. What will be the slope of any line perpendicular to it? Positive? 7/3, right? So let's say I just chose this point right here. And I want to draw a line perpendicular to this one through that point. So from here, I would count up 1, 2, 3, 4, 5, 6, 7, and run 3. 1, 2, 3. Draw the line. Do those look perpendicular to you? They do me. They look perpendicular. Lines that are perpendicular have opposite reciprocal slopes. So if I have a line like this, y equals 2x plus 4, and another line 4x plus 8y equals 7. Are these lines perpendicular? What's the slope of the first one? 2. Then what slope does this one have to be perpendicular? Negative 1/2. Do y'all see that? Now let's see if it is. 8y equals negative 4x plus 7. Remember, you tuck it in there and shove the 7 back. And then you divide. Y equals negative 4/8x plus, we don't care, equals negative 1/2 x plus, we don't care. Are they perpendicular? They are. You see how you just make the decision? Now, we're going to come back to this and actually write some lines that are parallel and perpendicular to given lines. So I'm going to leave this up here, but I'm going to erase the rest of this. We're going to use that as our template to put things in. And remember, I told you they'll always give you a point, but they'll make you find the slope. So consider with me. Example 3 says, write the equation of a line that passes through negative 1, 1. So my point that they're going to have to give us is negative 1, 1. I'm going to replace it right here. And by the way, before I read any more, look it up here. Just having the point, I can write this much of the line. Y minus 1 equals something times x plus 1. According to our little template here, the x value, which is negative 1, has to go here, and I have to subtract it. So this is x minus negative 1. Yeah? The y value has to go here. It was positive 1, so I'm going to go y minus 1. And I left a gap for the slope because I don't know what that is yet. But if they just hand you the point, you can write that much of a line just like that. That's the only piece that's missing. Okay? Then it says, after it gives you the point, it says, on example 3, page 1858, if you want to see the words, it says, write the equation of a line through the point negative 1, 1, which I've already accounted for, that is parallel to y equals 2x minus 3. What's the slope of that line they handed us? What's the slope of the line we're going to write? 2. All we want out of this is its slope. And since it said parallel to, whatever slope is in that one is the slope that's going to be in my line that I'm trying to write. Once you get all the gaps filled in, that is the y1 and the x1, which is from the point, and the slope, which is from that line. Once you get all those in, then you got to do two things. You got to turn it into slope-intercept form, y equals mx plus b. First, by distributing, and then by getting rid of this, in this case, adding. Did I lose anybody? Anybody? See the algebra? Distribute, solve for y. So just to prove to you that we have accomplished what we said we would, let's take a look at this line. The line they gave us was 2x minus 3. So I put a minus 3, and I would go up 2 and over 1 for the slope of it. Goes like that. Like that. And then the line that I supposedly that I wrote that's supposed to work, supposed to be parallel to it, starts at 3 and goes up 1 over 2. And it's supposed to go through the point negative 1, 1. Negative 1, 1. Oh, look, it's going to. So not only did it go through the point it had to, it's also parallel to it if you graph it. You good? Okay. Moving on, it's going to get a little rougher than this. This was your first taste of it. So use the same template right there. Come up with another point and some other way to find the slope. Let's look. Example 4 says, write the equation of a line passing through 2, 3 that's perpendicular to another line. Passing through 2, 3. And again, I can write this much already. See how the 3 and the 2 switch places in the writing? Gotta go to the y, gotta go back in first. And then it says perpendicular. Oh, perpendicular to 2x plus y equals 2. So I need the slope right here, and I can't see the slope in that line. Can't see it, so I solve for y. By kicking the 2x over and tucking it in where it goes. Now I know the slope of this line. What am I going to write here? Positive 1/2. Because this one's slope was -2. The slope of my line is going to be positive 1/2. You got to change the sign and reciprocate it. Are you with me? Then we do 2 things to clean it up. First of all, distribute. Did y'all see that? That 2 times 1/2 turned into a 1. And then y equals 1/2 x. That's -1 plus 3 is plus 2. And again, to show you that this actually worked out, I'm going to graph this one. It starts at positive 2, and you drop 2 and run 1. That's like saying 2 over 1. So there's the first line they gave us. And the other line is supposed to go through 2, 3, which is right there. And this is supposed to be its equation. So I'm just putting that on there. It's supposed to go through there. I'm going to start at 2, and I'm going to rise 1 and run 2. Oh, 2, 3 is right there. That's 2, 3. Okay. And so it does go through 2, 3. Does it appear to be perpendicular? That's not a great drawing, but does it appear to be perpendicular? All right. So that wasn't too bad. Okay. Now is where it's going to get tough. If you haven't been paying attention up to this point, pay attention now. This takes quite a chain of thinking, and you've got to do it on this grid. Oh, I taught you these things right here. This is going to become very important now, this midpoint. I never seen it yet. So here we go. See other examples. I haven't taught this. I haven't seen this for. Oh. We'll do the example they've got because I can't. Maybe I'll do one of the monitoring progress ones. No, I don't want to tell you. I'll just do their example. Oh, it's right here. Okay, sorry. It was sitting right here. It says see other example, and it's sitting right there on the page. Okay, all right, never mind. Here we go. Here's what we're supposed to do. I want you to look at the words for example 5, and then we're going to do it to this set of exercises. This example that I've got here, it says, we are to find the distance. Oh, we're going to need that at some point. We are to find the distance from the point 1, 0 to the line y equals -x plus 3. What? So I'm going to put a different example up here because that one's far too easy for what you're going to be faced with. So I'm going to give you one that's as hard as the one you're going to deal with. So we want to find the distance from the point. I'll put it over here. Point. Let's say -4, 5. And we want to find the distance from that point to this line. That's all they give you. Find the distance from that point to that line. This falls back to what we learned yesterday a little bit. What I would do if I were you is get a piece of grid paper, and I got paper for you if you've lost yours or whatever. And I would plot the point. There's your point, P. And I would graph the line. Starts at -2, and you rise 3 and run 4. I try to make it a little bit straighter than just free. Okay, so here's our line. That's our point. And I want to find out how far it is measured in these units. How far is it from this point to this line?
Draw a perpendicular line to that line.
It has to, yes, you're right. The line that we draw through P, or the segment that connects P to this, has got to be perpendicular to this because we discussed yesterday that distance means the shortest distance. So what's the slope of this line? 3/4. Says it right there, right? What's the slope of the line that goes through P to this is gonna have to be?
-4.
Okay, so in this case, we've got a point and a slope. The slope's gotta be -4/3, yeah? So I can write this, y minus 5, -4/3 times x plus 4. Do you all see the writing of that, even though I erased your template kind of thing? Y minus the y coordinate equals the slope we've chosen, which is the opposite reciprocal of that one, x minus the x coordinate, but that's negative, so we're gonna put a plus in there. Are you with me? To straighten it out, that's gonna be y minus 5 equals -4/3 x minus 16/3. That's really gross. Ugh. We got to kick the 5 over there. That's going to be y equals -4/3 x. And we got to take -16/3 and add 15/3. Do you see why I'm renaming this 15/3?
Yeah.
Need a common denominator. I have -16/3 here, and I want to add this 5, but 5 written as thirds should be 15/3. So -16/3 plus 15/3 is going to be -1/3. Do you agree? Everybody good? To graph this line, however, I don't have to actually have this equation, although it will help. I mean, it's just hard to deal with thirds. Look, I'm going to have to come down a third. That'll be about right there. And from there, I'm going to have to drop 4. So I'm going to drop by thirds. It's going to be 1, 2, 3, 4. And then run over 3. 1, 2, 3. I could do it that way, and that would be fine. But I could also just start at this point, because I know it's got to be on the line. I could just start there and drop 4 and run 3. I could do that too if I'm just trying to graph the line, and that's all. So, however you want to do it, graph the line that you actually wrote, or just rise over, run the slope for P right there. However you want to do it is fine. They're all going to be on the same line. Does it look perpendicular? Here's the hard part. You're going, that wasn't the hard part? No, that's not the hard part. The hard part is trying to find the distance from here to here. Because to use this formula right here, you have to know this point. What the heck are we going to find that point? Isn't it the one point on this grid that this line and this line share? Now we've got ourselves a system of equations. I got to solve this system. Y, I'm gonna write it over here only to make more room. I'm not, anyway, y equals 3/4 x minus 2, and y equals -4/3 x minus 1/3. I got to solve that system. I got to find the x and the y value that makes both of those true. Do you remember how to solve a system? The easiest way in this case is substitution. What I'm going to do is rewrite this equation, but instead of writing y, I'm going to write this because that's what y is equal to down here. I'm going to substitute this for the y up here. Looks like this. 4/3 x minus 1/3 equals 3/4 x minus 2. Do you understand the substitution? Everybody clear? Okay. Now I've got to solve this thing for x. First thing I'm going to do is get rid of my fractions by multiplying every term by 12. It's the common denominator. We want to find a common denominator for all the fractions. That's how I'm going to clear the fractions. I'm going to multiply every term in this by 12. It's the same thing as multiplying this side by 12 and this side by 12. You can do that in algebra. You can multiply both sides by the same thing. 12 is the common denominator. That will eliminate all my denominators. So I'm going to put a 12 out here to remind myself what I'm doing. Okay, now watch. There's a lot of arithmetic here. If I multiply 12 by this, I can, remember, it's always over 1. I'm not going to draw that for you. Write it up there. I could either say, well, that's -48/3, which is 16. Or you can say, well, that's in the numerator and that's the denominator. So 3 cancels with a 12 for a 4, and 4 times that remaining 4 is 16. Either way, you get that. Did you catch that? Did you? What's in the next term then? What's that next number? -4. Because 3 cancels with the 12 for a 4, and 4 times 1 is 4. That's how I see it. You good? What's this one going to give you? 9. And this one? And 24. You have to hit everything, even though there's not a fraction. You have to hit everything with that 12. That eliminates the fractions. I do that as quickly as I can because I hate fractions. Are you there? Now we continue solving for x. I'm going to add 16 to 9. That's 25. And at the same time, add 24 to -4. That's -20. Do you agree?
No,
-4. Oh, yeah, +20. That better? Okay. And then 20 divided by 25 is 4/5 if you reduce it, which is a really gross number. However, that is the x coordinate of the point of intersection. 4/5. How do I find the y? Plug it in here or here. Which one do you choose? First or second one? First one. Okay, so we have y equals 3/4 times 4/5 minus 2. You see the 4s will cancel here? I have 3/5 minus 2. 2 written as fifths is 10/5. So 3/5 minus 10/5, -7/5. Do you agree? See if that looks about right. That's going out 4/5, so not quite all the way, right about to there. And dropping 7/5 would be 1 and 2/5. So there's 1 and about 2/5. It's about right. Pretty good, right? But you can't tell that from this. You actually have to do the math. Great. Now we've got a point. That's awesome. It's this one right here. 4/5, -7/5. And this one was -4/5. We still have to find the distance between them, but we got 2 points now. But we still got to find the distance. Look at this mess. We still got to do the distance. So the distance is going to be, and this time you might want to grab your calculators or maybe not. It depends on how really good at arithmetic you are. But I got to find the distance between those 2 points, and it requires us to take the x's and subtract them. So it's going to be -4 minus 4/5 squared plus 5 plus 7/5, because it's minus a negative, squared, and then we square root the result. Now you can, if you've got a decent calculator that I told you to buy, you can type that all in at once. I'm going to grab mine. And you would type it just like I wrote it, with parentheses and everything. And I'll kind of show you what this looks like once I get it typed in. Type it just like it says, right on the home screen of whatever calculator you've got. You start out with a square root. It probably opens up in a parenthesis, -4 minus 4 divided by 5, close it, square it, plus 5 plus 7 divided by 5, close it, square it. Ew, I needed parentheses around the whole thing so I could square out the whole thing. Sorry. Hang on a minute. Oh, is that what you just said? 8?
Yeah.
That was amazing. That it came out that way. Usually it comes out some decimal.
Go in there. 8.
Now that it's all done, let's take a look at what we did so that you can kind of see the whole sequence all together now that it's all complete. They gave us a point and a line, and they said find the distance from this point to this line, which means you had to write a line that was perpendicular to that line because distance is always a perpendicular distance. So we found the equation of a line. We had this line already, and we used -4/3 for the slope, and this point wrote a line, like we've been practicing today. So we got our line. We still can't find the distance from here to here because we don't know what this point is. So now we have to fall back on our algebra skills and solve this system by substitution. And it came out ugly. X came out to be 4/5. We had to plug it in. It was gross. Come out to be -7/5. Verified it on the graph. That's about where that cross point is. Just make sure. Now that we have this point and this point, we have to apply the distance formula. Crank that out. Have the calculator skills to get that finished. So the answer to the question is 8. But look at the work. Write a line. Solve a system. Find a distance between 2 points. And it helps if you graph it along the way so you can see what you're doing. You won't have very many problems to do like that today, but when you hit those, they're going to be rough. You do 3 hefty things. Lots and lots and lots of math there. A lot of your exercises will be like what we did before, though, where they say, here's a point, here's a line, write the equation of a line parallel to this one. That's 1/10. Takes 3. I write the equation of a line, gotta solve a system, gotta find the distance. Okay, I'm done with that. You ready for the numbers? Just a second, I gotta adjust this. Mr. Gee borrowed my book last year and he changed some of my assignments and I'm trying to see why he left some of these out. I'll give you his, this is less. How about that?
Yay.
Okay. All right, here's the assignment. Number 2, 4, 5 to 11 odd, 13 to 21, 23 to 29 odd, 33, 4, and 43. What's that? That's 17. Not that many. Well, actually, this is more. He took out the odd part of one of them. Do his. Good, different.
His is more than yours was?
Yeah. He did 13 to 21, and I had 9 to 29 odd. And he did 23 to 29 odd, but he did 13 to 21. Let's see what that is.
How long before she has?
Oh, those are good
Maybe we
ones.
should do the last assignment.
Those are good for you.
Alright.
What? What was the question? Just do it. No belly aching. Just get after it. Anybody need any graph paper?
Hopefully me. Might as well take some. I don't know what happened to my other one.
They might ask you to graph some of these, but I would definitely graph these monsters here. So you can see what's going on as you progress. Oh, sorry, I should have cut this off before. There you go.